Hey everyone, today's lecture is on primate behavior. As you can see, I'm at my home again, and in a different location. We've got a little visitor with us. Let's see if she's taking a nap right now. So this PowerPoint's actually pretty quick, and in class I'd maybe take a little bit longer because there are quite a few videos, but obviously you guys can watch these, after you watch this PowerPoint. So I'll just go through and talk about a few things, probably mention which videos, because there actually are quite a few that I put on this PowerPoint, the ones that I'm really hoping you watch. So if you're like, oh, I can only have time to watch a few, I'll kind of guide you. But so once again, following along on the PowerPoint. The first slide, after the title slide, right? Why do we study non-human primates? So now, we're talking about the primates. This is the primate section, and we briefly discussed like primatology on like the first PowerPoint, right? The first lecture, like what is anthropology, and we went through all of the subfields of anthropology, and then within biological anthropology, we talked about the subfields within primatology, being one of those things. So being a primatologist, wide range of things that you can do in terms of research. You could be looking at behavior, like social behaviors, mating behaviors. You could be comparing that to humans or not. You could be focusing on just, one particular species of monkey or lemur. You also could, look at a bunch of different species because you're studying locomotion patterns. So there's a lot of things you can do, right? So in terms of how we, relate primatology, how it's connected to anthropology, really it's because, like I've said before, and hopefully this is one of those things you really, really remember, is humans, we are primates, we are also apes. And so of course, looking at the larger group of apes or the larger group of, primates is, since we are a part of that group, makes sense, And of course, there's going to be a lot of overlapping things regarding, humans and the other primates, whether it's apes or monkeys. There's going to be a lot of overlap between our behaviors. Obviously some differences. We're all, different and unique species in our own way. But there are definitely going to be some differences. And so for this section, there's going to be a lot of interesting comparisons, like this is different, this is similar, like how do we kind of connect this particular trait or this particular behavior with what, we do or who we are. So if you're kind of going down this list, you can see some of those things, like as a primatologist, things you might study, like I've already kind of mentioned, but we've got like morphological comparisons. So morphological means like the body, like the shape of the body, comparing, bipeds to quadrupeds or humans, to chimps or something. You can get really broad with it. You can get really specific. Behavioral comparisons, that's like a big one, right? Looking at, violence and aggression, looking at, primates and their sense of community, and if there are a hierarchy within a particular species versus another. So all of those types of behaviors, and then of course understanding the evolutionary path. So thinking of all of the currently existing primates, but also the primates from the past, and how in that deeper sense we're all related to those earliest primates, or even the earliest mammals, and how we all all of those branching events, all that cladogenesis, until we get the most recent species in primates. And then of course a little bit more, so things like even diet or intelligence, that's actually a really interesting one. Hopefully you guys will watch some of the videos on that. So moving on to the next slide, you'll see a little bit of a reiteration of what we talked about in the previous one. So remember the previous one, talking about classification and primates, so we went through those traits that all primates share. Some of them were physical traits, some of them were behavioral traits, so we went through those, right? So this slide, and I guess just this slide is just kind of reiterating a little bit on those behavioral ones. So you see we've got that we have that period of being a juvenile, really long period of being a juvenile, so we reproduce slowly. If you recall from the previous one, that humans amongst the primates, we have the longest time period of being a juvenile. For us it's about 14 years, but for other primates it's a long time too. So chimps, it's I think chimps is 7, and orangutans is 8, and compared primates to like non-primates, where you might be an animal that within 6 months of being born you're already producing your own. So a lot of other animals have a very short period of being a juvenile, but primates as a group, we tend to have longer periods. And then of course we look at the apes more so than monkeys tend to have longer ones too. So this is all kind of going hand. Sorry, I've got like a dog hair on my nose or something all day. What was I going to say? Oh yeah, so this goes hand in hand with like larger brains we as primates have, versus non-primates. And then of course that emphasis on learned behavior, all that social behavior that we learn as primates versus non-primates not typically having as much. So all of those things kind of like work together. The next slide. So a topic called sociobiology. Now, in the 1970s, there was a book written, and this is, you can see on the PowerPoint is an image of this book. It's called Sociobiology, the New Synthesis, and this was written by a man named E.O. Wilson. Now, currently, this is not anything that's controversial. His ideas have been completely accepted. In fact, we have subfields of anthropology and like dedicated to focusing on these initial ideas that he had back, 50 years ago. But at the time, they were definitely controversial. Hi, baby. So the main focus of what his book looked at was, one, it didn't really focus on humans. I mean, this is kind of similar to when Charles Darwin wrote on the origin of species. Essentially no mention of humans. But when you're talking about every other life form besides humans, obviously we know that we can extrapolate that. But even he knew at the time it was going to be hard for a lot of people to hear. And so eventually that happened, So kind of similarly with sociobiology, he really goes into, all like forms of life. Because he's looking at, like animal life, because he's looking at behavior. The main focus was, or like the main premise of this whole thing was that up until this point in the 70s, none of the scientists had questioned, evolution in terms of the body, like anatomy, stuff like that. That of course, bodies will change through time. We're going to see one species, looking a little different and then evolving into something else in terms of like the actual body structure, right? Anatomy, soft tissue, bones, all of that stuff. But his idea was that we also can look at the evolution of behavior, and it really coming down to, well, the brain, a physical organ, subject to the processes of evolution, just like all the other organs or parts of the body are. So, that hadn't really been focused on at that point. And so, of course, he all the different ways you can, elaborate on that, like all the different types of behaviors, at what level, subconscious, conscious, are we talking about, a rabbit or a highly intelligent, chimpanzee, and like anything and everything in between that, So this was very controversial at the time, and the main reason because now we would think, oh, of course we know behavior and evolution is related, because even in like a Psych 101 course, you typically learn about evolutionary psychology. There's at least a small section where you learn about some of our behaviors and stuff, how it's clearly related to evolution. And any anthropologist would say if you further your career in that, you would learn that most behaviors, really for all animals, is a direct result of evolution. Like, this is nothing controversial now, but at the time it definitely was. And the main reason why, and there was a lot of back and forth in academia, like for decades about this, the main reason why was because those who didn't agree with sociobiology basically made the argument that it basically said, like, the whole idea of sociobiology was basically saying that there's no such thing as free will, and that it's all just a whole mechanism of, something going on in our brain, everything's at like that subconscious level, that we aren't actually as the individuals that we are actually making any of the choices. Like, this is a very oversimplified, summary of it, but this is essentially what the controversy was. And there was a lot of back and forth, and the proponents of sociobiology were like, look, maybe that is maybe that's true. Maybe there is no such thing as free will, if you look at all of, life forms, animal life, or even before, like the earliest forms of life, and you see, like, when do we start seeing these, like, interactions between an individual and the environment at the most small level, like a single-celled organism. It's going to be something very simple, like here's a physical stimulus, and there's a physical response. The physical stimulus could be something bumped into it. The response would be it moved away. The environment and the individual, those interactions are going to be very simple at first until we become more complex as individuals, all these earliest forms of life, multi-celled, and then we get, so on and so forth over billions of years, right? And so the argument is, well, the individuals, all the different animals along the way are, different types of animals, like their complexity increased. So in return, the environment, complexity increase, like those two things playing off each other. Like it just seems as if we're making these, we or, whatever other animal are actually having like the forethought and making, complex decisions. But in reality, is it just like an evolutionary trick that just the environment's more complex and our reactions are more complex to where it seems as if we're actually consciously making a decision? You can understand how there's a lot of like philosophy in general, but also like philosophy of science and stuff that went into this whole like, debate. And like I said, it's lasted for a long time. Even now, no, not really. Like I said, we have whole fields dedicated to this. In fact, I think that's kind of on the next slide. Yeah, before I go to that slide though, just so we're still on the same one, the one that says sociobiology. You can see some of the bullet points though, looking at, behavior and like all these different types of behaviors, because even in class, I've discussed with you, this behavior, whatever, mating, resources, whatever, and we talk about the behaviors and how those are all influenced by evolution. So now it's nothing controversial. In fact, we teach it at the intro level, but back in the day, the people just got, a lot of scientists were so angry because they basically were like, literally as a scientist, some of these people said, well, that might be true for other animals, but humans are special. Like literally, this is what they're saying. And other scientists were like, how can you say that as a scientist? As a scientist, you should have the opinion that you shouldn't be making value judgments over which one's better or worse or whatever. That seemed as if that's what they were doing. Because if you keep on that train of thought, you're like, okay, well, how do we know that we don't have free will or we do? This is what I'm saying, like all of these like philosophical questions. But you can also get out this with real science, like neurological studies and stuff. And a lot of it is pointing to the fact that we probably don't have free will in the way that we think we do, And then, of course, that everyone's going to have some kind of existential, crisis or question about all of that, which is, fine. But it's an interesting thing to think about, And I think a lot of scientists would say, well, some of it's probably not free will, some of it is. But there are a few of us, probably myself included, who would say there's probably not really any. It's just a very complex system that we exist in that makes it seem as if we are, individual entities beyond just like a computer with soft tissue, One of these, there was just a lot of back and forth in a lot of these articles back in like the 70s and the 80s. And one of them basically was like, oh, what are we, just like robots? And someone responded, well, yeah, probably, right, So a lot of back and forth on that. Okay, so moving on to that next slide. Let's see. Oh, so like I said, some of the subfields already, like that we have now, inspired from sociobiology. So we've got, like I mentioned, evolutionary psychology, ethology, behavioral ecology. So these are all fields that, like in different ways, examine evolution and behavior. So now we have whole like subfields dedicated, to this exact thing. And if you continue in anthropology, like say you want to do a bachelor's or something, you would probably take courses where this is talked about at great length. The next slide. So here it says primate intelligence. Here are two videos that I really want you to watch. They're probably like, 4 minutes each or something like, probably, I don't even know if they're that long. So these two, and I would say that watch both of them because they do go hand in hand. Basically, I'll kind of explain it, but you really have to see this. It's really cool. So basically, there were these studies, multiple studies done, but they they took chimpanzees and they taught them how to count, and like that in itself is already incredible because they're like using our human like symbol system, right? Like how to count, like what that means conceptually, the order we do it in, what the numbers look like all of that, right? And so I'm going to draw something in a second. So that in itself is interesting. But then what they did was they have these numbers. They had the chimps in front of these TV screens, monitors, and they had numbers pop up, and the chimps had to, touch them in the correct order. So it would be like 1 through 9, it comes up, and they were taught to go, 1, 2, 3. So they would count, and when they touched the number, like on this touch screen, that one number they just touched would disappear, so they can go 1 through 9. So already super impressive, right? But then a step further, what would happen is once the chimp hit the number 1, all of the other numbers would disappear, and they would still have to remember where they were. And they could do this very easily. And basically the pattern would be different each time. So, let me just draw a quick doodle. So let's say you're looking at a computer screen, you're the chimp, and it's, let's see. Give me like a couple seconds. Okay, this is just a quick doodle, but imagine you're looking at a computer screen and it's looking like this, and you would be like, you're the chimp, you're like, oh, I'm gonna touch 1. Once the chimp touches 1, all of this disappears, and the chimps have to remember, like, there's like a grid, they have to remember where it was, and they do it in the correct order. So once they hit 1, they have to then go 2, 3, 4 without any of these being there anymore. And so insane. Impressive enough, but they do it so fast. When you watch this video, you'll be like, it's insane. Like, they will take like half a second to look at the screen and touch the 1 and then just go boom, 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 boom. They remember it really easily. Versus they have some like humans do it, and the humans, like, they spend like minutes and minutes looking at the screen to study it, and then when they finally hit 1, they typically only get a few of them. Like, they remember like 1, 2, 3, and they forget what the rest of them were on the screen. So the chimps can do that. And then on top of that, kind of even beyond that, which is already just insane, they'll have it where only let me just show you real quick. Okay, that's erased really well, but you can see, like, it would be only some of the numbers. So not just like 1, 2, 3, 4, 5, 6, 7, 8, 9. It could be like 1, 4, 5, 7, 9, and the chimps would still know. So it's kind of taking away, like, okay, it's not just they memorized it in a particular order. They really understand it, and they're doing this quickly. Yeah, like they would do this. The chimps would continue to do this over and over again. It would be like they're like eating a snack, because they get a snack. Typically, they get a little piece of apple or something every time. You okay? I got a hairball over here. Oh, okay, she's fine. What was I saying? Oh yeah, so they're doing it really, really quickly. And so when you definitely watch these 2 videos, and you'll just see they're just like, yeah, eating a snack, and they're just like do 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 do, like it's like, and the humans are like, they can't do it. It's crazy. So the whole point of this is to say, when we talk about like intelligence, or when we talk about humans and chimps and like big brains, this is actually really important. I'm not sure if I mentioned this on the previous PowerPoint, so this is a very important concept. So when we're talking about intelligence, right, or bigger brains or cognition and all of that, so when we talked about that with primates, we said, primates have larger brains than like non-primates. Now, we don't mean absolute brain size, like, oh, this is 1,000 cc's and that one's 700 cc's. It's not about, that's what we call absolute brain size. It's not about absolute brain size. It's something called encephalization quotient, or EQ. Encephalization quotient. What this is, and you can write EQ. Let's say it came up on something, you could just write EQ. You wouldn't have to write the whole thing. What this is a measure of is, let's say you were graphing body mass and brain size, because this is what it's looking at. The concept is, given whatever animal, given your particular body size, we would expect to see a brain size of XYZ. When it's higher than expected, this typically maps onto higher cognition. Oh God, we're all just coughing over here. So let's say I'm like, oh, I'm gonna make a graph, and let me get this in view. Okay, I'm making a graph, and I'm gonna plot the points of like all these different animals. Man. Of course, I'm perfectly fine until I start recording, right? So I'm graphing, different animals, different body sizes, different brain sizes, and I'm gonna draw like a regression line. Like any individual above the line versus below is typically going to have what we call a higher EQ. Ooh, man, that tickle just will not go away. Oh, I don't want to cough the rest of the time. Try to wrap this up. Oh my God. So when we talk about like bigger brains, or we talk about intelligence, like apes having a high amount of intelligence, it's typically a reference to this whole concept, like I said, of EQ. Like the brain is larger than you would expect for an animal of that size. And so, humans have a high EQ. All apes have a high EQ. But plenty of other animals have high EQs. So just really honestly think of any intelligent animal, and typically they're going to have a higher EQ, like higher than the average, right? So plenty of animals like we can all think of that are highly intelligent, right? So of course, primates in general, but especially apes. And then, like elephants, dolphins, pigs, highly intelligent. So typically, like I said, we see the higher brain size versus the body mass, and that typically maps onto higher cognition. But the cognition, or those levels of intelligence, are going to be different for every species. So in this example with the chimps, it's like, yeah, they are superior by far in this particular cognitive practice, whereas we might be better at something completely different. Okay, so moving on to the next slide. So here it says more on primate behaviors. There's quite a few videos. I would say the definite one, you'll get a good laugh out of it, is the very last one on fairness. I actually don't want to describe to you. Well, I'll just say briefly. Basically, they did the study with capuchin monkeys, and they had like two capuchin monkeys like side by side in two different, cages, and they were giving them treats. The capuchins had to do a simple task. They basically take a rock from the researcher, and then they have to give the rock back. And if they do that, then they get a little treat. And so there are two capuchins side by side, and they see each other, like at first getting the same treat, and then later getting a different treat, and then you can imagine some interesting ways they react to it. So definitely watch that one. It's really good. And then the next slide that says theory of mind. So there are two videos here that really go into theory of mind and how to test it. Basically, theory of mind is the concept that we have the ability to recognize ourselves as an individual in the world with our own interests, desires, perspectives, opinions. Not every animal has this kind of like, I don't want to say self-awareness is not the best term, but it's kind of sort of an okay term, I would say. But not all animals have this, and there are different ways that you can test this. And so these videos kind of go into different ways you can test it. Like one of them is, it's called the mirror test. So if I were to, like, and they've done this with human children, because there's only a certain age when it starts to happen, but they've done it with like apes and stuff. Let's say I want to testify, someone's like, oh, does Alicia have theory of mind? They would put like a mark on my forehead with a colored marker, and then a little later they would kind of get me in front of a mirror, maybe make it not so obvious, but like, oh, let's go to this mirror, and when I look in the mirror, if I just either I look right through it, I don't see anything, or I think it's someone else, because a lot of animals, either like dogs, they look in a mirror, they don't, either it just doesn't click, or they think it's another dog, right? But for those who have theory of mind, it's they realize something else is going on. And the way you confirm that, especially with young human children who maybe can't articulate any of that, or definitely with non-humans, is when the animal sees themselves in the mirror, they're going to see that spot, right? The colored spot. They reach on themselves. They don't reach towards like, oh, what's that spot on that creature over there, and they reach to the mirror. They reach on themselves. So they understand, like, this thing I'm seeing in the mirror is like a representation of what I am. They understand that concept. And so not all animals can do this, and this leads to a whole bunch of other types of intelligence. And so you can see here in this image, crows and magpies have this ability. No surprise, highly intelligent, right? The apes do, you know, including humans, of course. And there's a few that have this, but it's definitely meaning that you are thinking at a much higher level. And like I said, the video goes into a couple different ways they test this. But basically what this means is that you have the ability to recognize that you are separate and different from other people, that your perspectives could be different, you could have different desires, opinions, you know, what someone says or what someone sees isn't always what you saw. Things can be tricky, you know what I mean? So a higher level of thinking. And then the last slide is about language. So these I think I have 2 videos. I'm trying to think what the second one is. The first one I know is definitely on Coco the gorilla. I would say definitely watch at least that first clip. If you're not aware, like I grew up, we all knew who Coco the gorilla was, right? But she was a gorilla. She was taught sign language, American Sign Language, and so she could communicate via American Sign Language with the human researchers. It's an amazing thing. There are so many documentaries online you can find about Coco and just like the work they were doing at the Gorilla Foundation. And she's not the only ape that's been taught American Sign Language, but she's definitely like the most, you know, well known. She only passed a few years ago. I think she was in her 40s when she passed, and just her whole story is just incredible. You know, she was able to articulate her thoughts and opinions on things, and it's just amazing. Anyway, okay, so good. So this one's kind of 26 minutes. So perfect. We'll wrap that up, and I will see you guys on the next one.